年以上前にね、アメリカはそのブレトンウッズっていうところで、金本位体制の戦後の経済の体制について、もうすでに会議をやってるわけです。それ日本が負ける1年以上前で、その時アメリカの国内の株価っていうのはどんどん上がってる。もう戦争勝ってるの分かってるから。それでも日本はずっと続けたんだな。そういう抑止するような戦争を。でこれはまあ調べれば調べるほどね、もう信じられないような変な作戦を、下手な作戦を立ててるし、まあ日本のそのなんていうかな、まあ、天皇制をうまく利用したその軍部の暴走ぶりというのはいかにひどいかというのは歴史を調べれば知るほど分かります。ということで何か質問があるかな。で、まあ、そのことは今日のこの資料にもいろいろ書いてあるけれどもね。ですからそのなんていうの、まあ、国際関係論というのはある意味でね、平和論でもあり戦争論でもあるんですね。ですからその日本のね、一番その魅力的な部分っていうのはやはり平和を表に出す国家だという、平和を標榜する国家なんですね。例えばノルウェーもそうだし、北欧3カ国なんかそうですね。自分から他の国に侵略するとか戦争を仕掛けることはまずありえないというのは世界中の人がそう思ってる。だけども最近はだいぶ変わってきたんだな。自衛隊を海外に派遣しようという動きが非常に露骨になってきてますね。これはまあ後で中東のことでもやるんだけども、ジブチという国があるんで、エチオピアのその紅海の向かいに、でそこにはね、もうすでに海上自衛隊の基地が作ってあるんですね。それは中東から石油が来る船を護衛するためというんですが、これは見方によってはいつでも自衛隊をもっと強化して派遣して、アメリカのその軍の動きの一翼を担うことですね。要するに米軍の一部になって自衛隊はどんどん活動できるというシステムをもうすでに持ってるんで、日本は。でそういうことにぜひ皆さんに気づいていただきたいと思いますね。何か質問ありますか？じゃあまあ言っておきますが、僕は左翼でも右翼でもないし、極めて考え方はリベラルで柔軟ですから、大丈夫かな？良い。質問ないですか？大丈夫ですか？ OK。Now it's your turn。それじゃあ工科大学の OB のウィンモール先生に、英語で講義をやってもらいます。それでぜひね、その講義が終わったら質問してほしいんだな。これは日本語でも英語でもいいし。でね、講義があって質問をしないっていうのは実は失礼なんで、相手に対してね。で、アメリカの、欧米の大学はそうだけど、質問するとね、実は学生の点数って上がるんで、これは実は得点対象になるんですね。まあ、それはともかく分からないことがあったら、ここが分かりませんでもいいし、ここはもっと詳しくでもいいし、いろんなことを聞いたらいいと思います。はい、ではウィンモル先生にバトンタッチします。はい、拍手。
Thank you very much, Professor, for giving me a very great opportunity to be here and give a lecture. And I'd like to say hello to everybody here. I think I will try to speak slowly, and I think everybody can understand me. Well, the topic today I'm preparing to give you a presentation is about the chaos theory. Have anybody ever heard about that? No? Have you ever heard about the chaos theory? Yes? Okay. Here is the... Okay, it's coming. I will talk about the chaos theory and technology. My name is Wimol, and I'm an assistant professor in electrical engineering at the head of Intelligent Electronic System Research Laboratory at T9. I'm now with the Department of Computer Engineering and the Master Program of Engineering Technology, Thai-Nichi Institute of Technology. I think I met some old friends here. Okay. Firstly, I would like to introduce you about myself. Okay, this is me. Actually, I got PhD here. I'm your senpai. In 2009, I graduated from here. And my research interest is about the chaos theory, intelligent systems, large-scale integrated circuit or LSI circuit designs, and also the computer algorithms. So the question is why I'm here. That is the most important thing. I would like to give you an inspiration, Inspiration. When you study something, you have some theory, you can apply or adapt your research or your life probably. So is that correct word, sir? Hila make inspiration. Okay, so that's the reason I'm here. Okay, so I think you will get inspired by my lecture, and I hope that all you guys will like it. And first of all, here is the presentation outlines today. It's about the introduction to Thai-Nichi Institute of Technology, the chaos theory and its applications, perspective on future technologies, and we're going to have the question and answer sessions later. Okay? Slower. Okay. Okay, first, introduction to Thai-Nichi Kokyo Daigaku, Thai-Nichi Institute of Technology, or TNI, where I'm with now. Okay. Here's the photo about Thai-Nichi Institute of Technology. We have four faculties. At TNI, we have the Faculty of Engineering, including automotive engineering, computer engineering, industrial engineering, production engineering, and also, yeah, that's all probably. And also, we have the Faculty of Information Technology, the Faculty of Business Administration, and a graduate school. Okay, here's the picture of TNI. Do you know what? TNI and KUT has a very long relationship. We started MOU, Memorandum of Understanding. Kochi University of Technology has been our partnership since the 1st of June 2012. That means we have long relationship until now, already 3 years that we has been partnered together. And we every year have the TNI KUT summer school programs. Okay, this is the photos from this year. This year, as I say. So you can have chance to meet a new buddies, have cultural exchange programs, lab visit, and you're gonna have chance to visit some a very famous place like the Royal Palace or the old city like Ayutthaya. Okay, so if you're interested in this program, you can apply for next year. Okay. And this is the news on the website that we had some activities, some excursions to the citizen factory, and also some cultural exchange activities like this. Okay, that is some introduction about TNI and KUT relationships. Now I'm going to start about the chaos theory. As I said, has anybody ever heard about chaos theory before? Raise your hand, please. No? Never? Yes? No? No? Yes, okay, you're working on chaos theory. All right, let's see. Has anybody ever seen these movies? Chaos. You know that? No. This is the chaos in the movie. So we have many versions of chaos. You see, it looks very scary and some kind of very chaotic, right? Chaos, 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 order of chaos. So this name is very interesting, It is chaos. I think the country is right, probably. Maybe chaos in Japanese language. Well, this is the movie, but in reality, we can apply this theory to every field of study. I will show you afterwards, okay? Let's have a look here. Okay, everybody knows the linear system, right? Very simple, very basic mathematics here. When you think linear system, you can have equations. For example, this one, you can easily have equations. For example, x plus 2y equals 5. And another equation is 2x plus y equals 4. Simple, right? Easy, right? Right? Okay. But On the other hand, for the nonlinear system like this, I have a simple question. Can you find equations of this phenomena like this? Like smoker, like the smoke, like this one? Can you find the equations for this kind of phenomena like this? It is some kind of turbulence. It's not easy to find equations, right? So the perspective today is we're going to move from linear system to nonlinear system. How can you find equations for this kind of nonlinear systems? You know, I have some simple question for you. Do you know the two-sun problem? Same distance in gravity. See, you have two suns. Okay, this is sun number 1, and this is sun number 2. And the Earth is between these two suns. So, because of the gravitational theory, the Earth has to be rotate around the sun, right? But what happens? What if we have two suns? The way that the Earth gonna rotate, rotate around these two suns, what is gonna be? Any imagination? Any question from you? Any ideas? What's gonna happen? How about you? Any ideas? Any ideas? Because we have two suns, right? We have two suns, and the Earth is in between. So the Earth has to be rotating around the sun, right? But because the current system, now we have only one sun. Okay? So the way it rotates around the two suns is like this. It is chaotic, unpredictable. Sometimes it's go this way, but sometimes it's go that way, rotating like this, chaotically. This is the very classical question for like more than maybe 100 years. Because currently we have only one sun, right? So if two suns happens, it's going to be like this. It is chaotic. So it's unpredictable. Very interesting, right? You see the butterfly effects. The butterfly effects. The flap of the butterfly's wing causes the tornado. Do you know what? When you think about chaos theory, it starts from something very small, but a very small change, like the flap of the butterfly's wings. It causes a tornado in America, for example. Even very small change in the initial conditions, it causes dramatically changed in like very big system like this. Have you ever seen this picture before? The butterfly's wings, just only one flaps. Actually, it is applied to economics and also the politics as well. Okay, I will show you later. This theory was started by Edward Lorenz in maybe 30 or 40 years ago. Okay, the butterfly effect is the sensitive dependence on initial condition in which a small change in one state of a deterministic nonlinear system can result in large differences in the later stage. You could see from the time dimension here, at the very beginning, okay, there is nothing changed. But from when the time goes there like this, so it causes dramatically changed. Lawrence experienced, because at that time he was trying to model the convections of the atmosphere. But he thought that, oh, maybe there was some fault in my computer experiment, because when you change the initial condition within like very small digits in the floating numbers, it caused something different. So at that time he didn't believe. He thought that his experiment was wrong. But finally he found out that no, it's not, because the system has a very special characteristics like this. So small change in the, like this one, small change in the initial conditions cause some dramatic change in the bigger systems. Okay? So the chaos theory is a field of study in mathematics, okay, with application in several disciplines, including meteorology, sociology, physics, engineering, economics, biology, and philosophy. Here, you could see the joke. For 2 decades, I've studied phase-space nonlinear equations and strange attacks, And there's nothing in here about dinosaur escaping. Can you get this joke? Well, even you study hard in this theory, finally there's nothing. Because it's just a joke, because this theory is not easy. But it is applicable to many fields of study. I will give you an example. Anybody from engineering school, raise your hand, please. No? From environmental science? Yes, one student. And how about you? Which department you're from? Which department? 이거 내가 알고 있어. 저거 information.
本当に応募できる。
でも今日は英語ですね。はい。Okay. So because all you guys are come from different departments. Okay? Different departments. So I will give example to all of you so that you can understand it very easily. Okay? Am I speaking too fast? I think it's too fast. Okay, I'm gonna keep a pace for you. Let's see. Meteorology, the climate. You know the climate. The climate is actually chaotic and cannot be predicted. It's unpredictable. Let's have a look here. The sunspot. The sunspot numbers complied by European observation here from the year 1850 to the year 2010. Did you see that the number of sunspots are quite chaotic? You know the sunspot, right? Everybody knows that, right? So the European observations, they kind of noticed the numbers of sunspots on the sun, and this is a graph of the number in each year. And you could see that it is non-linear, and they are not the same. So it's quite unpredictable because it is non-linear. It is non-linear. Do you have laser? Laser. Okay, thank you very much. So you could see that the time has changed. When the time passes, you see, the result in here is not predictable. It's not linear. So it causes the climate on Earth, and they're chaotic. It's not linear. Okay. Let's see another example here. The total solar irradiance, or the energy received from the sun, the monthly means and the annual means here, they are quite chaotic and non-linear. So, can you find equations for the climates? Any ideas? Any ideas? How about you? Any ideas? Can you find equations? No, maybe not, right? Because it's not linear, you could see that. So, the chaos theory has been applied for meteorology in order to simulate and predict the number of the total solar irradiance there. We kind of introduced the linear system. No, we cannot predict it. But when we apply chaos theory, okay, now you can see that the system is deterministic, and we can find equations for it. Once you can find equations, you can get the result. You can solve equations to get the result. Okay? Let's see more example here. Sociology, a conceptual framework useful in analysis of society. As you know that, like the complex system here, epistemology and ontology here, the society is chaotic, like the relationship among people. Okay? Like if you have friends and your friend also have friends. Here, if you take a look on your Facebook, okay? So you might have the mutual friends, right? On your Facebook. So the way that a single human interact to others, they are quite chaotic, and the system becomes like this. These are the relationships of the humans. Okay? For example, you are here. So you know one friend and your friend knows other. So you have many friends in your life, your family, your friends, and your society here. It's not linear. So social complexity is one of the topics that we are trying to model it. if you can model the society using mathematics, that would be great. Okay, see, it's quite interesting, right? So heuristic and unordered. So human involved, not mechanics, and complex, not ordered. Interesting. So society is chaotic system. Okay. More example. Physics. I think all of you already studied physics, right? Who never studied physics, please raise your hand. You never studied physics. So what are you studying now? Economics. And management. So physics is quite interesting subject, man. But I think in your high school, you might have learned physics. So everybody study physics, right? Right? Physics. You know physics. Physics. Hi, okay. Physics, okay? Like this one, the three-dimensional dynamic equations. This is just a equation, okay? But we have three equations. What is the result here? That is the time domain when you solve this equation. So, some equation doesn't have exact answer. Like the 1 plus 2 equals 1 plus 2 equals answer. 1 plus 2 equals 3. Okay. Simple question. 1 plus 2 equals 3. Thank you very much. But that is a number system.